So for our first example for one mean confidence interval here, let's break it down into parts. First thing I noticed right off the bat, I want to do a confidence interval because I want to get an idea of what the average GPA for all Loyola students is. I'm not trying to prove a hypothesis, I'm not making an assumption here, so I know it's a confidence interval. Just want to get a general idea of what things look like. So in doing a confidence interval with one mean, the first step, like every confidence interval, is to go ahead and list everything. With a mean problem, I'm going to list x bar, that's the average of my sample. I'm going to go ahead and list s, that's the standard deviation for my sample, n, and then based on n, I'm going to list my degrees of freedom, and I'm going to use that to find my t-score. Remember, we're going to use a t-score with our mean problems, and that's because we tend to have a smaller sample size with them. So I've got the things I need to list. Let's go ahead and pull them out here. My average GPA is 3.4. Awesome. I've got a standard deviation of 0.3. So while people are spread out, it doesn't look like they're enormously spread out. N is 25, and degrees of freedom, remember, is always n minus 1. So I'll have 25 minus 1, or 24 there. Then what I really need to do is find my t-score, and in order to find my t-score, I need three things. 1, need degrees of freedom. 2, I need my confidence level. And 3, I need my t-table. And so, poof, the magically appearing t-table. Now to find the appropriate t-value or t-score I'm going to be using, the first thing I need to do is narrow it down to what confidence level I want. In this example, we want a 95% confidence interval up here. So what I'm going to do is I'm going to look only at the 95% confidence level. So I'm going to be looking only at this column right back here. Now, aside from the confidence level, I also need to go ahead and narrow it down to my degrees of freedom. I have degrees of freedom 24 up here, so I'm going to go ahead and find the 24 degrees of freedom row and trace it across. Which means the t-score I want is this overlap right here, which will give me a t-score of 2.064. So once again, I took my confidence level up, my degrees of freedom over, and found the intersection of there in order to find the t-score. Now that I've got my list done, the next step I need to go about is my calculations. We need to calculate SE, and that's going to be S over square root of n. So I'll have 0.3 divided by root 25. For mean problems, we'll always keep 2 decimal places. So here I'm going to about 0.06. Third step is going to be my interval. My interval will be x bar plus or minus t times SE. I'll get 3.4 plus or minus 2.064 times 0.06. When I sub this interval, the lower value should be right around 3.28. Once again, keeping 2 decimal places for mean problems. And the upper one, 3.52. Now, because this is an average problem, these are not percentages. I don't have to do anything weird with them. I'm just going to leave them just like that. My final step is to go ahead and summarize my answer. And like every confidence interval, we start with, we are 95% confident. And I know I'm 95% confident because that's what I used to figure out my t-score. And also what they asked me for up here, 95% confident interval. So we are 95% confident that and we're not talking about percentages here, right? We're talking about that the average GPA of all Loyola students is between 3.28 and 3.52. Notice I'm not putting a percentage sign on there because these are not percentages. And just to make sure we've got all our information, I'm telling you how confident I am, I'm telling you what I'm talking about, I'm telling you who, and I'm giving you my interval. So once again, what we said here is based on these 25 students, assuming it's a random sample of Loyola students, we're making this inference that we think The average GPA of all Loyola students is somewhere between 3.28 and 3.52, and we're 95% confident on that.